Welcome to part 2 of your introduction into C#. In this video, we're going to focus on Boolean expressions that allow us to control the flow of execution and branch our program into many possible paths of execution. In our previous video, we created a program that basically executed from top down. That means that every statement that we created, such as this one, the next command to execute was right beneath it, and the next statement to execute was right beneath it, and so on and so forth. So all of these statements executed in the order that they appear according to the computer, and there is this little mechanism within the computer called an instruction pointer that basically says once you've executed this statement, you can find the next instruction at the next position in memory, which might be this. And then the instruction following that was found here and then here. So that instruction pointer can be manipulated through what are called flow control mechanisms. And there are several different kinds. We're going to focus on two in this video. One is called an if-else statement, and the other one is called a switch statement. So let me go ahead and I'm going to delete what we had here from our previous video, and I'm going to just start from scratch. So let's go ahead and create a new variable. And in this video, we're going to try to produce an answer to a math question. So I need an integer, and I'm going to call it my response. So I'm going to be asking the user of this program to enter in a number, but I don't know what that number is going to be. Hence, it is a variable. So let's put in a message on the console that tells or instructs our user of the program to enter in a number, like what is 5 times 5? Question mark. And then we're going to capture that response by saying response is going to hold the value of console.readline. Now, as I type this out, we should expect an error. So I'm just going to hold off there for a second, and in pops my red squiggly line. Now, just as a review of what I pointed out in the first video, I said that this variable called response is an integer. And in part 1, I said that console readline returns a string. So if I hover over this console readline, the top of the flyout says string console readline. That indicates that when you're capturing something from the read line, it is returned as a string, a bunch of characters. So this spot in memory called response is supposed to hold a number, not a string of characters. And therein lies the error message. I cannot put into memory a string of characters when I'm expecting to put a number. So what can we do to solve this problem? Well, we need to convert this string into a number. So the error message at the bottom of this flyout says it cannot implicitly do it. So we need to explicitly, which means we need to type a way to convert this number. And it's pretty easy. I can just, right after the equals operator here, I'm going to write convert dot to int 32, which means convert it to a 32-bit integer. And then I'm going to surround that with parentheses, and we're going to go on our merry way. Now, in a real-world sense, I would also want to try it and parse that first to make sure that what they typed was not just blank space or not a number at all. Otherwise, that could create more errors. But for now, we're going to pretend that the user is going to put in exactly what we are asking for, and we're going to put in a number to demonstrate. So now that we are holding the response, let's test to see if they get it correct and give a different message when they get it incorrect. So I'm going to say if, and then I'm going to have a left paren and a right paren. So a set of parentheses that will say if response double equals 25. So here I'm testing to see if the number that was typed in the console is 25. If it is, we can put console.writeline, you are correct, exclamation point. And this is what it's going to say if we type it correctly. So let's go ahead and run the program. We're going to say start without debugging, and it'll say what is 5 times 5? And if I put 25, it will say you are correct. What if we don't get it correct? I'm going to run that again, and I'm going to put in that number. It didn't say anything at all. And the reason why is because if this condition is true, it will do whatever is between this left-facing curly brace and this right-facing curly brace. Otherwise, this entire block will get skipped. So therefore, the path of execution was to run this line, and then run this line. Then the instruction pointer will figure out, is this Boolean expression right here true or false? If it's true, the next instruction to execute is here. Otherwise, it says go to whatever is past this right-facing curly brace and execute beginning here. So that is our first step in manipulating the flow of execution. Another key point here is that the expression that is in between these parentheses must always be either true or false. And that will tell the computer where to go next. So when it's true, it executes at this point, and when it's false, it will go to wherever that right-facing curly brace is and begin executing commands that follow that. So if I were to add in an else, and then some more curly braces, I could say console.writeLine, you are incorrect. So this tells the computer that when they have a true statement in here, do this, and when it's false, do that. Two possible things, but it's only going to do one or the other, not both. Let's go ahead and run this as an example. I'm going to click Start Without Debugging, and up comes my window. And I'm going to say 25, so it says you are correct, but it did not say incorrect. So that whole block of code got skipped. It will not run this. If I did that again and I put in a different number, it says you are incorrect. So the first part got skipped. So there's a demonstration of how the instruction pointer determined that on that second try, this was the next instruction to execute, and it skipped this one entirely. Okay, so other possible things that could evaluate to a true or false could be like a greater than or a less than or even a not equals. So sometimes you want to see if two things are unequal. So testing inequality would look like that. But a common mistake is to put a single equal sign, and that is an assignment operator. So don't make that mistake. It has to be a double equals. Okay, moving on, what if we wanted to have 3 possible things to execute or more? Well, we can add an else if that will get tested between if and else. And we can have as many as we want. So let's now change the program to ask something different. So here I'm going to just take out all of this, and we're going to start a scenario where there could be 3 possible things to pick from. So I'm going to say string, and I'll call it context. We're going to ask the user if they're from the past, the future, or the present. So I'm going to say console.writeLine, and are you from the past, future, or present? Question mark. Okay, now we need to store their response to this. So that's our context variable. What context are you from? And we're going to store the console.readLine. Now, readLine, once again, is a string, so I don't need to make a conversion in this case. So when I hover over this, it says it's a string, and so is this variable. This variable holds a string. So we can just straight up say context holds the value of console.readLine. And now we can test test what that response is. So if the context dot equals passed, and this would be case sensitive, by the way, and then I'm going to have a set of curly braces. So let's just say console dot writeLine. What do you think of the future? All right, let's test this so far, and then I'll explain what's going on. So I'm going to say start without debugging, and if I put in past as the answer, it says, what do you think of the future? All right, let me go ahead and push enter, and it will have no further commands to execute, so it closes out. This right here is asking, does the phrase match, does it equal past? And that can be true or false. Yes, it is, or no, it is not. And this is how we would check to see if strings match. So keep that in mind, that when we test a string, we want to make sure that we use the appropriate way to test whether or not the strings match. So the context, which is whatever they typed, does it match past? Let's keep going. I'm going to say else if context dot equals future. We're going to say console dot writeLine. What happens in the future? Okay. And we should have another else if context dot equals present. And then in this case, I'm going to say, would you like to visit the past or the future? All right, so let's go ahead and test this. I'm going to start without debugging again. And I've already done past, so let's do future. So if I said I'm from the future, it'll say, what happens in the future? And then if I started it again and I checked the present, it says, would you like to visit the past or the future? And then I can push any key to continue. But what if I pushed something else? So if I typed in something else like blah, 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 it skips everything. So another good thing to do here is to put an else that does something when none of those situations occur. So console.writeLine, I need to know where you are from. All right, so if I were to start that again, and actually let me start it with debugging, and I typed in a whole bunch of nonsense, it'll say, I need to know where you're from. That's called defensive programming, and we'll keep that in mind as we go forward. So an if can be followed by as many else ifs as we want, and just for defensive programming purposes, we should finish up with an else whenever these do not occur. All right, and this is how you would make the program branch or execute along many different paths of possibilities. So next up, we're going to talk about a different way to create this exact same effect with a switch statement. So to introduce the switch statement, I'm just going to delete everything that we have here and do another example. In this case, let's determine what a test score means in terms of its numeric value versus its letter grade. So to do that, I'm going to create an int called test score. I don't know what that value is going to be, so hence it's a variable. Then I'm going to write to the screen, enter a score from 0 to 10. Then I need to capture that input by saying test score holds the value of, and just as we did before, we need to convert the string input of the console read line to an int 32. So console.readline. And now I can create my switch. So a switch operates very similar to an if-else. It starts with the switch keyword instead of an if, and then we need to put a Boolean expression inside of parentheses. So whatever I put in here needs to be an expression that it can compare against all of the case statements as either true or false. So I'm going to put in test score. So this is a numeric value right now. And then within curly braces, I'm going to put case statements. So if I said case 0, it can compare test score and 0 for a match. If that's a match, it's true, and it will execute whatever I put after the colon. Otherwise, it's false, and it will look past there. So in case of 0, and in case of 1, case of 2, 3, 4, and case 5, they are all exactly the same. So I want to do the same thing for each of these cases. I can stack them up like this and do the same result. So this is actually creating a scenario that's a lot like an OR operator. So all of these combined together will do the same action, and I'm going to say console.writeLine, and I'm going to say you got an F. Then I'm going to use a keyword called break, and break will now separate this block of case statements from the next case statement, which will be a case 6, console.writeLine, you got a D. Now if I don't put a break right here, what happens is these statements fall through to the next instruction. That means that all of these are stacked up, and this case falls through to this case, which falls through to this case, until it comes to a break. When it hits the break, it will exit the switch and then continue executing at whatever instruction is after this right-facing curly brace, which indicates the end of the switch. So in between each case, we need a break when we intend on jumping out of the switch. So now for step 7, or case 7, I'm going to just start copying this stuff and then changing what I put just to speed things along. So this is a C and this is a B, and then I need 2 more. So I had 5, 6, I need to change this to 7, 8, 9, and 10. And then the letter grades would be F, D, C, B, A, and A+. Okay, now just as we did in the if-else, it had the final else statement, a switch has something called a default. So when I don't put anything in that matches, I can run something by default. And in this case, what I'm going to say is console.writeLine, you didn't enter in a score within the range of 0 to 10. And then I'm going to break. So if I were to, let me expand this up a little bit. So this is our complete switch statement. This is an example of falling through. So all of these statements are going to run the same command. They are all going to run you got an F and then break. When it hits this break, it jumps down to here and skips the remaining ones. But if it's a 6, it will say this and then break out. If it was a 7, it'll do this and break out. 8 it will do that and break out and so on. So that's how a switch operates. Let's go ahead and test it. I'm going to click Start Without Debugging. It prints our request for input of 0 to 10. If I put in a 3, it says you got an F. And then let me run that again. If I put in a 7, it says you got a C. And let's get a perfect score here. We're going to enter in a 10, and we got an A+. And that's what a switch statement is and how to create it. And finally, I'm going to introduce to you what enums are. An enum kind of goes hand in hand with if, else, and switch statements. And they represent values or data types that we get to make up to make our code more readable, and we can follow along with it a little easier. So enums are declared at the top of your class. So on line 11 here, I'm going to squeeze in an enum that I'm going to call day. And this day can only have a value of Monday, Tuesday, Wednesday, Thursday, or Friday. So this is our declaration. This is its data type. This is what we're going to call this variable, and these are all the possible values surrounded by a left and right curly brace. Now let's go ahead and modify what we have down below to use one as an example. So here I'm just going to wipe out what I had in the main method, and I'm going to create a new variable of the day data type. So just like we did in part 1, variables start with a data type, and this data type is called day. We just made it up. Now we have to give a name to it. This program that we're going to write is going to be talking about school days and what to do on a particular school day. So might as well call my variable school day. So I'm going to ask the user of this program to pick a day of the week, 1 through 5, and then I will present them with what to do on that day. So I'm going to say console.writeLine, enter a number from 1 to 5. So far we really haven't done anything new on line 15 and 16. But now I need to store the value of what they have, or whatever the user picks, as a school day, which could only be Monday, Tuesday, Wednesday, Thursday, or Friday. So let me type out the command to do this, and then I'll explain how it works. So just as before, we need to take our variable that's going to hold that value and say, in this case, variable name, school day, is going to hold the value of, and it's going to be of a day data type. So this is called casting when I do this. And I'm going to be casting a numeric value as a day. So in this case, I'm going to say, in parentheses, convert to an int 32 console.readline. And all of this is what we've had before. So previously we know that readline is a string, and we need to get its numeric value, and we're going to convert that into a day of the week. So up here I'm going to add an equals 1. So if they enter in 1, then this will convert to the first day of the week, which is Monday. And the computer is smart enough to know if this is 1, then this is 2, then this is 3, then this is 4, and this is 5. So whatever number that we put in, it's going to be converted to a day of the week from 1 to 5. And now in our switch statement, if they put in a 6 or a 7, like Saturday or Sunday, we can handle that with the default case that I just showed you in the switch. So let's go ahead and build this. I'm going to say switch, and then in parentheses, I'm going to say school day. And now my switch is going to begin with the left-facing and right-facing curly braces. That marks the beginning and the end. And now I can do cases. So a day could be a Monday, colon. And then I'm going to specify what that student needs to do on Monday. So write line, and I'm going to say on Monday, complete the part 1 video quiz, period. And then I'm going to break. So this says if they entered in 1, which means it's a Monday, then just print this to the console and then jump to the end of this switch. But of course we have 4 other days in the week, so I could put in day Tuesday, colon, and then write out what we're going to do on Tuesday. And on Tuesday, we're going to complete the part 2 video quiz. And I'm just going to copy this and do pretty much the same thing for Wednesday, but it's going to be the part 3. And I'm going to change the day to Wednesday right here. And then I'm going to break. Oh, I forgot a break here on line what is now 26. So I got to add that in. Remember, that would cause these two to fall through. So we don't want that to happen in this situation. So next I've got Thursday. So on Thursday, and I needed to change that to Wednesday as well. And this to Thursday. And on Thursday, let's complete a programming challenge. And on Friday, we'll take a quiz. So console.writeLine. Okay, and as I just said a minute ago, what if they don't put in 1 through 5? So by default, we will have them say, or we're going to have the program say, sorry, that is not a school day. And on the next line, we will break out of the switch. All right, so let's preview our program here. But before I do, look at how much more readable this is. So on Monday we do this, Tuesday we do that, Wednesday we do this, Thursday, Friday, etc. This allows us to quickly glance at our code and read the intent of the code. So enums help us make the code more readable, easier to manage. And let's go ahead and run it now. Let's go ahead and click Start Without Debugging. And it says enter a number from 1 to 5. I'm going to put 1, and it says on Monday, complete the part 1 video quiz. And if I test another one, I'm going to say 5. On Friday, take the Unit 1 quiz. Okay, so that's what an enum is. This is how you declare it. And down here, this is how I used it. Now that we're at the end of part 2, before you go on to part 3, complete the part 2 video quiz located on Schoology to review the concepts that were demonstrated in this video.